Air Energy is the local representative for Rogers Machine, who builds these Kobelcos. We also represent the company, Dominic Hunter, that makes the dryers that we used on the project. I know you have more of these machines around the campus. This particular set is a little different than the last couple sets you bought in that they've rearranged the packaging a little bit of the units. You'll notice the cabinets now have a single cutout with a large electrical panel in the end. The older version of this unit used to have the electrical panel behind this panel and a separate box here for the programmable logic controller. And the biggest change is that the main electrical controls for the motor running gear and the logic controller are all in one central panel now. From a standpoint of installation, it works out in some ways because, and I think the reason they made the change, among other things, is that having the PLC on one side and the electrical box on the other meant that you needed full code clearance for two electrical panels. So you needed full clearance of, depending on where you were, either 36 or 42 inches out from this side and that side of the machines. So from an installation standpoint, they still look for at least 2 feet of clearance around the machine, but they're only asking, the only one that needs the electrical code clearance is this small narrow side. That's essentially what drove the change. The other difference between most of the other systems you have, most of the ones you have, if I remember right, Larry, are duplex systems. A lot of them are all 2 compressors. And the way the duplex systems alternate is basically there's no interconnection between the machines. You just program you just program them identically with 2 different pressure set points, and you tell one it's the lead machine, one it's the lag, and either every day or once a week, whatever you program it to at a certain time, as long as the clocks are within a minute or so of each other, whichever one's in lead switches to lag, the one that's in lag switches to lead. With 3 machines, the scenario gets a little different. The way this setup works is you have a master machine and 2 slave machines. So the master machine is number 1. So the front of that one will say it's the master and it's node 1. If you look at these, they'll say compressor 2, node 2. So compressor 1, compressor 2, compressor 3, and they're actually set up consistently node 1, node 2, node 3 as far as the sequencing is concerned. The biggest difference is that in the internal programming, node 2 and node 3 are looking over to node 1 to tell them what to do. And the programming is interesting from the standpoint of all 3 machines have the same basic program to operate the unit. The sequencing program is actually a separate subroutine that's called up. So the software for that is running on the same Allen Bradley PLC as the subroutine, but it is literally not connected with the operating software for the machine, if you follow. Aside from, basically what the programming does is substitute new values for the load and unload or start and stops in the existing software that operates the machine. That's really the only connection. So the sequencer portion of the program is totally separate. So if something goes wrong with the sequencer, you can literally take the machines out of sequence and run them as normal machines in local mode. And actually, if you look at the front screens right now, these are actually set up somewhat in that way. You'll notice you got 2 bars here, one that says remote and one that says lag machine. I believe that front machine, number 1, will say lead remote and will say lead machine. If nobody's touched it since I was here last. That one says lag too? Okay.
Same thing.
Okay, right now they're all in lag. Now here's the important thing. That lag means nothing if you're in remote. It's an artifact because these are sort of double programmed. And the reason for the double program in those, we can actually turn off the whole lead lag local system that's built into the unit controls and just put it in remote, where it'll just run off whatever, do whatever the sequencer tells them. The flip side of that is, if the sequencer crashes, it just reverts to whatever we have set into each one as a local control. So if we set one a little, we set them in 3 staggered things, or if they're all programmed exactly the same, then they're all going to come on and off at the same time. So by having the lead lag set up, if they get off the sequencer, they're going to operate either lead or lag depending on what they're set to. And if I remember right, what we did is we set number 1 with number 1 and 2 here with a lead and lag. So these two will switch between each other. And the third machine also has a lead lag, but the settings are a little different. So in truth, you'll end up with a 3-unit cascade depending on which one's lead, which one's lag.
So this is taking it out of that other sequencing?
That's if the sequencing is lost. If they lose communication, then they just default to local. And what settings they use in local will be determined by whether it's currently in lead or lag.
So for normal operation, it's all sequence. This is always going to be the lead compressor.
No, it won't be the lead.
Or the master.
It's the master,
Right, okay.
but the lead will rotate.
What I'm trying to say is this one is the one that's going to get the most use.
Yep.
It's never going to switch. That master will never alternate to this one and then that one, and these
Well,
are kind of like volleyball.
Oh no, the use will stay even on all of them.
Well, they will.
The only thing that's a master is, let's visualize it this way. We have 3 identical machines.
Yeah.
The other way to build this type of thing would be 3 identical machines and a sequencer box on the wall here.
Okay.
So all 3 machines rotate based on that sequencer box. The only difference they've done is from ease of use. They start doing sequencers if you have more than 5 machines, a separate box if you have more than 5 machines. They actually can do this type of thing for up to 5. They prefer it only, actually they'll try to convince you to put a separate sequencer on if you go up to over 4. But they can do up to 5 on this configuration. But what you really want to think of it as is that's the master unit. That's got the sequencer in it. And just think of this one as it's sitting here and the sequencer box is mounted right to it. The only difference is it's not a separate box. It's actually just another set of screens in the existing controller. But so that's the master unit. The one thing you want to bear in mind is if you shut this unit off to work on it, it's the master. It's got the sequencer in it. So when you kill power to this unit, you're killing that sequencer. So if you're going to work on the master unit, flip these into local before you shut it off. Yep, exactly. Right, you touch that remote button and a little screen comes up. Okay, there you go. And it asks you whether, what you want to be in, remote or local. If you put it,
Remote is obviously dealing with the master and local.
remote sends it back to the master. Local puts it in here. And once you put it in local, you can toggle the lead or lag and it's going to put it, and it's going to be based on whatever the...
So if you take the master out, then you would have to put both of these in local control, and then you would have to determine which one you want to be the lead and lag compressor.
Right.
You yourself. It wouldn't be something that would be done.
Well, basically, if you looked at both of them, and as I said, we'll have to look at what the settings are because it's been a month and a half. I don't remember.
This is the same as clinical building, right?
Pretty much. Yeah, that's the other one that's got 3.
Yeah, no, there's no lag in these anymore, is there?
As
Before we could set, 3 different parameters on each screen.
no, they've actually changed the programming. The way the sequencer works now is you set an ultra high, and you set a band where you actually want the system to run.
Yeah.
So for example, right now this one is set 90 to 100 with a high of 110. So if it overshoots,
That happens.
it'll allow it to go to 110 before, and then it just will unload everything. And it will go as low as 80. If the pressure suddenly spikes and drops to 80, the sequencer will start all three of them. Now the other thing the sequencer does, and right now it's evincing that sometimes you'll see, you'd think only one of them would load up right now if something happened. Theoretically, what can happen though is that if the dryer goes to purge or a bunch of the auto drains all fire simultaneously, which this one's still not online, right? Or is it?
It's not really. It's just,
Yeah, it's just deadheaded up to,
there.
yeah, there's nobody using anything. So while it's really not in use yet, and there's no real consumption, the pressure changes are pretty much just when the dryer, by default, runs a purge cycle, or the drains on the tanks fire. And the pressure transducer that runs, that's the other thing, is a master pressure transducer mounted in the pipe right here. That one is run back to this controller. It's the only one that's got the extra. They've all got their own internal pressure control. That one is operating the sequencer box. Call it a virtual sequencer box, but that's what it's doing. It's operating the virtual sequencer box. Now the real key with the sequencer is it also looks at the rate of change. So if the pressure drops from, say it's inching down and it's at 91, right where it's at 90, it's going to start a compressor. And suddenly the drain goes off or the dryer purges, and suddenly that transducer sees a 5-pound drop in half a second or a couple milliseconds. Sequencer knows it, sees how fast it's dropping. And if it drops 5 pounds in under like 2 seconds, it'll actually trigger a second machine. It'll trigger 2 machines to load and run. And if only one's in standby or only one's running, it'll start another machine figuring, wow, pressure's really going down, can't take a chance, we don't want to ever drop below 80, up we come. Right now it's said if it drops 10 pounds in that pulse, it'll bring on all three simultaneously.
Lag alarm will come on.
And if all three of them come on, the lag alarm will trigger. So it's once we get everything running, there may be some tweaking of the exact setting. For example, the factory originally set those at 2 and 3 pounds for the trigger. And I've now widened it to 5 and 10. Because at 2 and 3, all of them were starting every time, a drain fired. Don't need to, have it do that. But it's just need to understand is the algorithm's a little different. The old algorithm that's on the other one was you basically used to, on the old sequencer, they basically had you set, all right, our lead's gonna go, 90 to 100, lag's gonna go 85 to 95, and then the third one's gonna go 80 to, the third one will go 80 to 90. Which if you look at what the bands are in there, everything's set to still go between 80, maximum drop of 80 to 100, and 110 is the fail-safe. So it's really the same thing. The difference is that since it senses rate of change and it makes decisions on its own, so some of those decision-making parameters may need to be adjusted a bit to cushion it. If you really don't need all of them to come on or 2 of them to come on, then we can widen that out. But you really won't know until...
I'll probably call you once we get everything up online.
Exactly.
I don't know if I'm going to run all the buildings off this system or...
And also, right, that also depends. I know you guys love crossover pipes, and there's nothing wrong with that. There's nothing worse than not having enough redundancy.
In a facility like this?
Yeah, especially when you usually find out at a really bad time.
When you need it the most.
Yeah,
when you don't
exactly.
have it.
So, the ability to shift things around and put extra machines online is a good thing.
How complicated or how difficult would it be to turn one of these other 2 into the master?
It's actually a different program that would need to be loaded.
How long would it take? A day, 2 days?
It's a circuit board, isn't it?
It's built into, it's in the PLC. You'd have to, actually probably the simplest way to do it would be to take the existing modular chip off that machine and throw it in. The downside of doing that would be that the serial numbers and everything else would move over too.
I don't even.
Well, here's how I see this whole thing playing out. This one takes the big shit because it's the master. And
No.
these two are going to have to run sequencing.
I don't even use the master on the other one. I run everything. I run it all by itself.
I'm not faulting Air Energy or Rogers. I'm just saying that when you have one of something, that's the one that shits the bed first.
Yeah, if this shits the bed, you just gotta put that.
No,
Yep.
right. There's
Right.
a backup plan, but I'm saying it's going to take weeks to get this one back up.
Oh, no.
We're going to have to go back to that.
Rogers would ship you a new PLC and you'd have it in 2 days.
All right, it didn't work.
Yeah, Rogers is good about
I'm not
that.
trying to shit on your company. Don't take that the wrong way. I'm
Oh, no.
just saying that.
But one thing you have to understand that even though this one's controlling everything,
Yeah.
as far as runtime, they're all going to end up being even.
Right. As long as this one's the master and it's up and running.
Right, and it's sequencing all three of them evenly.
Right.
Now
What I'm saying is if this one dies out, then that whole part of that equation is gone.
Right. Now the other thing is, my personal advice is, anytime you're going to work on any one of them,
Yeah.
put the others in local.
Okay.
Do
All right.
what?
Anytime you're going to work on one of them, if you're going to shut it off and do something to it.
Because usually the
I mean,
maintenance
yeah,
takes a couple days.
if you're just looking at it to check something,
Yeah,
no
yeah,
big
yeah.
deal. But if you're going to turn it off and have it down for,
Couple days.
no, even more than 15, 20 minutes, put the others in local.
Okay.
That way you're eliminating any possibility that something you're doing. Because now bear in mind, the other thing that's going on with this particular iteration is there's a network switch in there. There's a network switch in here. There's a network switch in there. So the communication between these is actually an Ethernet connection between those switches.
Okay.
So that one is connected from there into the switch in here. The switch from here goes over to there. So they're all talking to each other. But by the same token, that's the master. I kill that, these two lose signal from the master, they revert to local. If I kill this one, the communication from that one is going through the switch in here.
Okay.
It's a powered switch. Kill this, switch loses power. It may
May or may not.
or may not. It depends how good the signal is.
Okay.
It may be able to propagate all the way over, it may not.
Gotcha.
Do I want to gamble on it? No. Put them in local.
All right. Cool.
The only one you can get away with shutting off without switching it to local is Tail End Charlie
The
there.
other two are like, whatever, dude.
And now bear in mind, if you look at these were actually bought 2 years ago. If you look at the serial numbers, I think they're on the end there. They're like 11 or 12?
Yeah.
11, right? So obviously the latest version of the machines is already evolved a bit. Cabinets are different.
Same
Panels
blow.
in the same place.
Same blow.
Yep, same air end, same everything else. But I mean, yeah, they keep evolving. They keep changing the machines a little bit as they get feedback. So most important thing, when you're looking at the screens, like all the others, or the newer ones, you've got the main screen here that gives you inlet pressure.
This is new.
You know, this is a new one. Your older ones don't have this.
No, we just got the interstage and the outlet.
They now have an inlet pressure gauge, so you can tell what the restriction is at the throat of the pump. Now the interesting thing about that is if your inlet filter is brand new, that's also telling you what your delta is on your intake pipe. So for example, if all three of these try to run and load, that's going to go a lot lower because they're all trying to pull enough air to compress down that
That one head.
intake pipe.
Yeah.
Yep. So your intake pipe is, you're coming in from outside and you're dropping into each one on the flange connector there.
So
But-
this is this inlet for this machine only?
That's inlet for this machine.
Okay.
Each machine has its own, again, all the normal controls are on each one.
Okay.
You can look at the sequencer from this. We'll get to that. You can see the sequencer front screen, so to speak, from each of these machines.
Okay. Cool.
However, the only machine that you can log on and make a change to the sequencer settings is that one. You can't make any changes to it from these. Yeah. So you get your intake, the other critical one, the interstage pressure, which as you all know, I'm sure, is one of the two things You gotta if you're checking, doing daily rounds or whatever, the recording sheet for these machines is you're supposed to take this pressure when it's
30 inches and
yeah when it's in vacuum while it's running. So this readout can have 3 different states. It can be at 0 if the machine's off. It can be somewhere between 0 and 30 inches of vacuum, usually somewhere between 3 and 15 inches, depending on the unit and wear and tear. When the machine is running unloaded, and then a positive pressure up to about 35 pounds. Although machines that top out at 100, it's probably going to be more around 26, 27. But it's possible, on a high pressure machine, it's possible for that to go all the way to like 42 pounds. Yeah. That's about as much as you'd ever see on one though. That's on a machine that's going to 150. You might see 42 on the interstage. Then you've got your second stage, which is your outlet. And then you've got your...
the outlet of the second stage.
Yeah, that's the internal pressure transducer that's in this just before the outlet pipe.
Okay.
And then you've got your oil pressure. And next page is temperature. Oh, sorry, went the other way. This one's your hours and your cycles. You probably know the running hours and loaded hours, and the most critical thing on these is the cycle times. How many times the inlet is opened and closed. Because these machines have 3 states: off, running unloaded, and running flat out. There's no...
Or broken.
Well, that would be off.
That would be off.
That would be you know, you have a hard reset. That's a hard off. The
trend chart, is that's right?
No,
What'd I do? I didn't touch nothing.
Push the wrong button.
That was sending torpedoes.
I mean, there's trending.
Careful, we're about to go underwater.
Game operation, you hit the side.
There's trending on the other ones, but I don't think it was that easily accessible.
No, there's a button you can touch to get to it, but it wasn't as easy to get to. The newer versions, you can just get right into it, set up set up whatever you want for.
The phone numbers changed too. Just kidding.
What's Beacon's doing there?
Nothing to see here.
Oh, Chip was here the other day. Reprogrammed him.
That's it. I can put it. I can put my number on his too. Hey, you know, there's room for everybody.
Listen, if you get in front of work, there's no sense going to work.
All right, and our temperatures. So we have, now that's a new one too. We now have an inlet temperature that's displayed.
Oh, okay.
So now you get something that tells you what the air coming in is. And first stage discharge, second stage inlet.
That tells you your interstage cooler is working real well. Your first stage cooler, because it's bringing in an 82, it's heating up to 142.
Yep, it's putting it almost within 5 degrees.
Yeah. Yep. Is that what it's supposed to be, within 5 degrees?
They're actually, you know, you're looking to have it within 20 degrees anyway. You're really looking, as long as this is below about 125, you're okay.
Yeah.
They don't want it much below 100 though, right?
Okay.
They want to see it somewhere 75 to 125. Yeah. Real trick is you don't want to go down into like the 60s. Because then you're making condensation.
Yeah.
It's actually about 65 or so, 65, 70, you'll start making condensation.
Okay.
So that's more of a problem with water-cooled machines than anything else.
Okay. Yeah, I guess that makes sense.
You know, it's one of those things. Oh, my water's real cold. Well, you know, we want your water to be, you know, 50, 55, but you start giving me 35-degree water, you may have to adjust your valves a little bit, because that's actually why if you got some of the water-cooled ones, they've actually got on the intercooler, they have a regulator on it, and on your aftercooler and your oil cooler, there's actually hand valves. With the idea being the intercooler will get regulated where it needs to be, hopefully.
Gotcha.
But the others...
Is that a manual regulator, or is it with a bulb?
It's with a bulb. Only on the intercooler.
The other two are hand.
The others are by hand. And there's a hand valve on that one too, but you pretty much set it and let the, you know, unless it's running too cold. But then the right thing to do is to adjust the regulator rather than just throttle a hand valve and
But you're taking the regulator out, it just has to go.
exactly. Some of the biggest differences. Pull it in the. Let's go in here for a second and look at what the passwords haven't changed. Those of you that know them.
Oh, really?
Okay.
It's the same password. I can never remember it until someone shows me.
Okay.
I don't know. What it is.
Interstage, alarm delays.
What?
1844.
What I really want to show you, I mean, obviously most of these things are never going to change. Obviously, you want to make sure the clocks are all pretty much within a minute or
Now,
so. If you're
with that password, I'm assuming to change that, any of these parameters, you just kind of sort of click on that, and then you can
yep, I can. If I hit that, I can go and change
do,
it.
do whatever you want.
Yep.
For instance, the clock. That seems to be
Yep,
like,
same thing
if
with
they're
the
a couple
clock.
minutes out, then you have to pull them back in, right?
Yeah, I mean a minute or two usually won't bother you, but if you
Well,
if you get
like
to the
10, 15 minutes.
right, if the the clocks are doing everything, typically with like anything electronic, they're basically being worked by the frequency of the electrical lines.
Yeah.
They're working on they're assuming 60 hertz.
Right. Right.
Now we all know it's never
60 hertz.
exactly 60 hertz,
Yeah.
depending on what's going on. So sometimes they speed up a little bit and get out of sync. So yeah, I've had a couple of issues where I mean they got to the point where they were like 2 hours out of sync. So of course you get somebody saying my lag alarm's going off. Well, yeah,
it is.
because at noontime that machine, or what it thinks is noontime, this machine which was in the lag or was in the lead is now switching to lag. This one was in the lag, but it thinks it's only 10 o'clock.
So I got 2
So,
hours.
right.
I'm still on break for 2 hours.
It's
asshole.
it's not it's not switching for another
You
2.
rules.
Not my turn yet. So of course what happens is they're both in lag. They both trigger.
Yeah.
What does the lag alarm do?
It goes on.
Hey, I'm
You
on.
got
Yeah.
problems here.
It's time.
Interesting. That's funny.
So you'll see the normal shutdowns and alerts, the same as they were in the older machines. First stage discharge, second stage suction, and you can see these are the alarm points and shutdown points.
So this is also giving you your current temperature too.
And it's showing you what it actually is. Now,
Interesting.
reason for this is obviously the way we test these is, all right.
Drop that down to
Yeah,
128.
we'll make that 128, and the alert light should go on.
Gotcha.
So
Have there ever
that's how you
been-
can test
has
them
there
without
ever
running
been
the
an
machine and
issue-
beating the hell out of it.
Has there ever been an issue where you have the alarm come in and everything looks like it's within parameters? You know what I mean? Like for instance, let's say this is 135 now, it alerts at 580. You come here, there's a high temp alarm, but this is still reading 135 at the time.
Well, bear in mind, that's going to trip based on what it is. So if it tripped and shut down, everything cooled down, that's going to read whatever the
So
temperature's
that'll
cooled
start
off
to
to.
drop back down. Okay.
Yeah.
You'll know what your set point is.
But the
Times two.
just demonstrate what I talked
I'm
about.
going to turn on first from now on, all right?
I noticed they're shutting down a lot sooner over here. How quick you shut them down?
Well, we'll see. Now the other stuff, lube oil. Now the inlet temperature will give you an alert, but it won't shut it off. So if your
There's
inlet
really
temperature,
nothing that it can do to control
right,
that,
right. But if your inlet temperature goes over 122, it's going to warn you that, geez,
Right, because you said that you don't want your second stage, your interstage, to be over 125.
So, yeah,
It's coming in at that.
hopefully we're not going to be sucking in 122 degree air from
There's
outside.
There's other problems. Yeah.
At least hopefully global warming isn't going to warm Boston up that much in our lifetimes. But,
That's really why we get this right here. Then, yeah, I'm sure this came out good heat.
now right now this one is set. Lead, this one's 85 locally now. This is local settings.
Okay.
So it's not running on these. It's running off the sequencer.
Yeah.
But if it goes to, if we set it in local, we're 95, 85, and 90 and 80, lead and lag. Okay, now that one is 90 to 100 and 85, 95. So when that one's in lead and this one's in lead, this one's actually, they're actually staggered.
So
Put that one in lag, you put this one in lag, they both drop. Now this one and that one's set a little differently, so it flips into the middle, so to speak. So when this one's lead, that one's actually, when this one's in its lead position at 95 to 85, that one should be lag.
Then this is all local control you're talking about right now, right?
Yeah, when it's in local.
Okay.
In other words, by doing the lead lag that way, I fool them so that if you have any air or any one down, when you put the other two in lead and lag, they will switch. They will be opposite. Without having to spend hours going, okay, what do I want to reset it?
Yeah.
Tried to make it, I mean, obviously you guys can change these, but tried to make it so if you take them out of remote, there's something there that's going to work them.
Yeah.
And work them in a way that you don't have to worry about.
Almost like a program sequence that you've come up with for them to.
Yeah, basically what we're doing here is we're doing the standard 2-unit lead lag, and I just rigged it so lead on this one or lag on this one is the same as lead on this one. So if that one's in the lead and this one says lead, they're still staggered.
Yeah.
So if it's lead, lag, or vice versa, they'll still shift and still. Now our shutdowns and
Emergency stop shuts everything down. Regular stop, it'll shut down the oil pump. Well, I think it goes the afterflow. Yeah. There's a stage screen.
lead and lag, they're all set for 10.
I think it goes
10 minutes?
Yep.
oil pump first.
Seems like they're shutting down a lot quicker
to
than
start it
that.
off, it goes oil pump first.
Now, that could be, again, they're not in local control. We have to look at what the sequence is set to do on the lags. Two things to remember, the temperature sensors are all identical. In other words, they're all interchangeable. If you know, if you've got a bad sensor in your second stage discharge, the machine won't run.
You got a bad sensor
But if you've got a good sensor on your first stage, if you're at your inlet, okay, the loss of the inlet temperature sensor is not a shutdown condition.
So you can flip it.
So you can steal that probe and put it to replace the defective one while you're waiting for another one to come if you want to get the machine up and running. And that's actually why they use all the temperature probes the same, because you can take the couple that aren't critical and swap them around. That's not true of the pressure sensors, because the pressure sensors, you can see here, the lube transducer is calibrated 0 to 100 pounds. That's its actual range of the transducer they use. The interstage is calibrated from 30 inches HG, so it's 0 psi absolute to 60 psi. To 60 psi.
Right.
And let's see. Yeah, the discharge is 0 to 160. So. And yeah, the compressor inlet transducer is also 0 to 30. 30 to 60. So actually the only two, now bear in mind, keep that in mind, because the inlet transducer can be swapped for the interstage. If we flip out of this and go back to the main screen on this machine, that pressure reading is coming from the internal sensor in here.
Yes. Yes.
So that this will only go forward, it won't go backwards. If this is lead, you can't make number one lag.
Right.
It goes lead, lag,
Right,
lag.
3 units.
It always goes forward.
Yeah, always lead, lag, standby, rotating through. So when that becomes lead, that's lag, this is standby.
So on and so forth.
Now, if you take a unit out of the sequence,
Then you can do whatever you want.
right, if one's out, and if you take it out of remote mode, then the sequencer knows it's out of remote,
enough.
so the sequencer will
Bypass
move. It'll tell you it's not. So let's look at our, as I said, we can see what's going on in the sequencer. We're just not supposed to make changes to the others. So, I can get to the I can see the settings, the simple settings. Yeah, that's all I can see from this one.
Okay.
The main sequencer screens, we'll have to look at number 1 in a couple minutes. First, we'll shut down this one, and because that should give us some interesting messages over there in a minute. I'm going to put it in local. Now, you notice when I put it in local, what did it just do?
Nothing.
Oh yeah, it did something.
Everyone offline. Shut down.
Important to know. Yep, it's going to say it lost communication with.
Station 3 now ready.
Yep. So just hit the acknowledge button to stop, silence the horn. Okay. The other thing you will note is this machine was in standby off the sequencer. When we just hit and put it in local, all our lights went out. Now we didn't burn the light out because what's actually happening here, it's the lag. And if we look at its set points, its lead and lag set points are the same as this one. So if this one's in lag and this one's in lead, and the first one's in lead, we've got a 3-unit stagger, which is again why I left it manual, so one can confuse it. But so this one's not going to come on until we drop down to 80, but it won't come on anyway because we're not on. When we put it in local mode, machine's off.
As long as the sequencer is up and running, right?
Well, if I put it back, here's the interesting thing. If we put it back in the sequencer, I'm going to put it back in remote. Now, it's blinking. Now notice what it says right here. This red line that comes up. In order to enable the sequencer, I got to actually have to hit the start button.
That's interesting.
So what you're doing right there isn't enough. You also have to tell it. That's almost kind of like sort of clicking OK on a mouse.
Yep, you're confirming it.
Okay.
So if you walk by and this light's blinking,
You got to do something.
you got to hit the start button or whatever to make sure it puts it back on the sequencer. Now right now we're in local. The reason I did that is we're going to kill the disconnect on this so we can open the cabinet. Now the nice thing about this one, yeah, let's put it right there. Compared to the others,
Yeah, I will turn it back on.
that's cool. Okay, they still have the oil filter, the oil pressure fault test device. Bear in mind, anytime you work on it, you want that little valve to be open.
Okay.
Say that again?
This little valve here, you always want that open.
Triggers the alarm.
Right, if we turn this off and we hit the start button and run the machine, in 10 seconds it'll shut down because of low oil pressure, because this line goes to the oil pressure sensor.
Okay.
Now,
Oh, okay.
the reason for this is people used to like we're going to test low oil pressure. So they would take the wires off the contactor.
And forget to put them back on.
So we don't start, well, even just testing it for 10 seconds. The one thing they never ever want you to do on these machines is run them dry.
Yeah.
That's why, for example, when we hit the start button, the first thing that starts is the oil pump.
Right.
And when it sees enough pressure, then it starts the main drive. When we hit stop, the main drive shuts off. The air ends start coasting to a stop. The oil pump keeps running another 10 or 20 seconds until it coasts to a stop before the oil
I
pump
noticed
stops.
that when we do our little annuals and we drain the oil out, like when you go to start it back up, there's not enough oil in the system yet. It'll shut down.
Instantly, yep. Because it's looking for pressure and it's also looking for circulation. But the trick with this is so that you can shut the sensor. Basically, we just isolated the pressure sensor that's at the end of this
You're
tube.
still getting oil. It's just not getting
But
the signal.
the pump's going to run. You're still going to get oil pressure, so you're not damaging the machine just to test the sensor.
Cool.
So we've got our intake. There's a filter on 4 thumb screws here. You drop it down. There's your air filter. Again, you want to change that at least annually. Probably want to inspect it monthly. You're coming down a long pipe with and there's a screen on the end of the intake or whatever. So, chances are you're not going to find any pigeons.
Right.
But
Angry birds.
Where is the inlet pressure sensor on
the inlet pressure sensor is actually, here's the temperature that's the temperature sensor.
Temperature.
That's inlet temperature. The inlet pressure sensor is actually mounted down below here. It's one of these lines.
On that bottom.
Yeah, it's coming off here in the base.
Yeah.
Okay.
Because the inlet pressure sensor is doing two things. It's telling you what's coming down here, but it's also telling you how much restriction you have across the filter.
Yeah.
So if that filter gets, even if you got plenty of flow coming down the pipe, if the filter gets real dirty, that's going to give you some kind of warning that your air filter, even if it's just starving from something else, what it's going to be pointing, that's the air filter. And if you take it down, the filter is absolutely clean. Okay, then did a bird build a nest?
Yeah.
Especially if all three of them are doing it. You know, did something finally figure out a way to nest or whatever. So our air is coming in here, going down through the intake valve. Those of you who've played with these machines before know that annual maintenance on these consists of changing the oil. Oil fills here, drain is on the far side. Changing the oil filter, replacing the load solenoid, which in this unit is mounted back there. A lot easier to get to than on the old ones. You'll notice all your pressure transducers and sensors are right there in a row. And if you ever have to change a motor, this one's a lot more, this is a lot more accessible than when the electrical cabinet was here, the other cabinet was there, because the only way to get to it was from the backside. And if you look at the backside, you can see that it's not fun to take apart.
No.
These are made to access, the others are not.
Cool.
So you got your inlet, you're going into the first stage air end. This is, again, compressing to about 30 pounds. Out of this through a fin cooler, up into the top and into the intercooler, the first stage cooler. Now there are three coolers with radiators here. First 6-inch here, this is the oil cooler.
Yep.
Second set in is the interstage or intercooler. And then the last one, which has a vent to pull air in, is the aftercooler. So your air goes in through the interstage, hits this moisture separator. There's a solenoid drain on that down below there. You'll also see there's a Y strainer just ahead of it and a check valve after it. That's all set up. So they actually put the check valve in there now. They didn't used to put those in. The check valve's there because they had so many issues with people piping both the drains to a common drain pipe.
Yeah.
No matter how much we told them that it's okay to pipe them if you pipe them individually. People always pipe them together. The problem being the interstage here, the air pressure in that's only going to be 30 pounds max going out.
Yeah.
The other one's going to be up whatever the max pressure is of the machine.
Get pushed back into that.
So if they both fire simultaneously, you can backfeed wet water, condensate.
Affects the air ends if it gets past that too.
Exactly. Your most critical thing here basically is actually your intake filter. And the second most critical thing is the condensate separator. The inlet filter, because that keeps particulates from getting into there. And the condensate filter here, because this keeps liquid water from hitting the second stage.
Which is really fucking hot.
Yeah, when you've got a screw that's running at 400 plus degrees and water hits it, the water explodes into steam. These screws are coated with a proprietary Teflon style coating, and when it explodes and blows into steam, it erodes the Teflon coating off and you degrade the performance, and you also tend to make the machine run hotter over time. Actually, that's pretty much how air ends eventually wear out and need to be replaced, is the coating eventually wears off after 50,000 hours or whatever. Yeah, you've got some machines that have been here a long time now. But the one thing that will accelerate that damage is hitting them directly with moisture. The other thing I'll mention is very important on these machines that if you ever do any work on them and check something, actually I have to look when we look in the cabinet. The latest versions, they're putting a phase protector in them. Okay. They never used to.
Phase protection?
Yep.
Okay.
And they never used to. I'm not sure if this, I said the last ones I started were made 3 months ago. They have it. I'm not sure if
this model has it.
But the important thing to remember about that is, or even if you're not relying on it, or lots of times if you've got flaky power, because a lot of phase monitors will, if the voltage goes off by 5%, they'll trip out. So a lot of places they get driven nuts by the phase monitors, so they jump them out anyway. The important thing to know is if you ever happen to change a motor or do something, or the power company did anything, and you have a any thought that they might have reversed the phases, check the machine very carefully, and obviously everything in the machine is in the same phase. So if you test the cooling fan or the oil pump and it's going the right way, you're good. But the important thing is never run them backwards. Because if you run these backwards more than about 30 to 40 seconds,
Really?
yeah, that 600 degree heat that's
Gets pushed
building
the
up
other
in
way.
here, it gets pushed the other way. Guess what catches fire?
Oh, awesome.
We had a guy with a 350 horse that caught fire that way. They did some work on it and they reversed it. And did not realize that it was, they did some internal work and changed the motor out.
They did it themselves.
And well, whoever rewound the motor the opposite way. So when they hooked the leads up the same way they were before, the windings were opposite. And it had a soft starter on it. It was only designed to go forward, but a forward signal to the windings now was a backward signal. And when everything else checked out, they figured, oh, they're all phased the same. We hooked them up the exact same way they were.
So we're all right.
Were all nice assumptions, you know, usually, except this time it wasn't. And they did manage to salvage the machine, but it was, let's put it this way, that one runs about 25 degrees warmer than its sister machines.
I'd like to look at all the gauges when that happened.
You know. So then your air comes back off that separator, goes into the second stage, gets compressed to the final pressure, goes to the aftercooler, and comes out of that and goes down, and the moisture separator for that is on the outside, where you can see it. Obviously, the things you're supposed to check every day are temperatures and pressures here. You're supposed to check that oil level. You're supposed to check that oil filter differential.
Is that new?
And
I've not seen that.
they've been on there for a few years now.
I guess it's not. Yeah, we don't have this on the ones over across the way.
Yeah, it's probably been 3 years, 4 years. Those are about 6 years, 5, 6 years old now, I think.
Yeah.
That pressure drop, can that pressure drop be seen up on the screen too?
No.
It's got like wires on it.
They do?
It's a signal. There's a switch inside it. If the differential gets too high, it goes in as a fault, and it'll tell you. Yep. Yep. So it'll
Oh,
fault.
so it'll come in on a pressure alarm versus that thing. Obviously.
Okay. So again, and on the back side here, some of your older machines may not have this.
Oh, that's a new demister, huh?
Yep.
Oh,
We've got a lot of people who are retrofitting these
Very
on now.
nice. I like that because that's going to keep the inside of that cabinet a lot drier. Because those demisters, they work real well if you don't mind picking the oil up off the floor.
Yep, that's the latest style on the demisters.
Goes back into the sump.
Goes back down into the base of the sump and
Very
trickles.
good.
Now, when we retrofit them, what we've actually been doing is, you know, rather than trying to drill and tap a hole in the base of the sump, we've been retrofitting them, and we put them up like this. But what we end up doing is we basically put the drain line where that elbow is. We'll put a T there.
So you take the elbow out and you put a T in?
Yep. So the drain will drain. Basically, it'll come off where it collects.
Yeah, yeah.
Now, of course, it can't do that when the machine's running and there's positive pressure going out. But as soon as the
Right.
machine shuts down, gravity will just bring it back in.
Oh, cool.
So it's.
Good deal.
So yes, they can be retrofitted on the older machines,
We should
and they do
that.
work.
I'm sick and tired of taking a bath every time I get into those things.
And let's put it this way: they started doing that because they started feeling it was an issue that
Well,
It-
even with a good demister, it's still like a big, you know,
As soon as it clogs down, it
Floor's
comes
oil.
drop anyway.
yeah.
Yep.
Now, I'll order 50.
Basically, in the back is just a motor, your squirrel cage fan.
Now, are these the same rotations, million rotations for CCVs or cycles for the CCV?
Yeah.
Okay.
Yep.
Million cycles, it's a million, right?
Well,
Yeah,
it's a million for Rogers, and we have 500,000.
Well, they all it used to always be 500,000. That's what it was. The
Oh, it
years.
used to be. Oh, okay.
And you know, basically, just going by history,
You've gotten them.
they came up to the point. Well, probably some of it's history. I think if you talk to the engineers at Rogers, they still like the idea of 500,000 from a standpoint of preventive maintenance, making sure nothing's ever going to go wrong.
It's usually 3 years for
But
us.
part of that is also competition. So when your competitor says, well, ours can do 1 million,
We could
I
do
got
2
you.
million.
well, I think what it was is,
I see a million and raise
yeah,
3.
yeah, basically they were at 500,000. The competition came out and said, we can do 600,000. So they decided, well, we're not going to,
We'll up the ante big.
We'll up the
Yeah,
ante all the
yeah.
way. We'll double it.
Yeah,
Go.
yeah, I got you.
But that's also, you have to understand, they make decisions on changes like this based on those data sheets that get sent in.
They're not just going to indiscriminately say that.
Because believe it or not, they do pay a couple, I'm sure you probably met the people that do it. They actually pay a couple of clerks whose job it is all those sheets that come in
Yeah.
get manually entered into a tracking database.
Yeah.
And if you call them, especially if you got a water-cooled machine, they can tell you what your coolers look like. If you've been sending the stuff in, obviously. But you always get those people who don't bother to send it in.
Right.
Now your airflow, obviously, as some of you noticed when you're leaning against the machine, comes in the backside. You'll notice you got some intakes here. You want to remember about these. Under this cover, there's another screen in there.
There is. Okay.
Oh, you took them out? Okay. Good. Most people don't. Which is not a good thing.
How would you get to it?
You have to take all these screws off and drop that. So glad to hear you took that out.
I suppose you could, yeah. That's not welded to that. It's just
Just that, see that one screw on that collar up top?
There's a
You
collar.
take that off and it just
okay.
stops there.
Cool.
How often, how crucial is it to keep these clean?
That's monthly.
Yep. Because that is your. This one here is the cooling air getting pulled in across the cooler. This one is the cooling air getting pulled in across the motor and the air ends. And everything goes out, blown out by the fan out the top. So if that gets clogged, and I don't think it'll be a problem here. I mean, the fun thing we get sometimes is, that's a nice flat surface. It's amazing how fast it overheats when somebody puts a 40-pound box
On top of it.
on top of the cooling vent. And that's an embarrassing service call, especially if you rode 4 hours to tell them that.
All set. $200, please. Yeah.
Thank you for coming in.
Yeah, 200. Yeah, more like about 6.
Whatever. Yeah.
But thank you very much.
Yeah.
I had a nice ride. I'm going to have a really nice ride
I'm
back.
gonna go to lunch at Hooters.
On you. As a matter of fact, if you take me there and buy me lunch, I might write this
we'll
up
forget
differently
about
so
it,
you
yeah.
don't look quite so bad.
I like that.
All right, so now let's look at the front cabinet here, which was the point of shutting the thing off. What do we have in here? Well, we have the manuals, but I will jot those down and get copies for you.
Not digital.
Yeah, obviously PDFs. I'm not gonna get the paper copies, no. All right, so the PLC, which used to be in its own separate box, is now sitting right up here in the top. So what we have is the whole bank of main logic. Thing to know about in these is this right here. There's a backup battery for the PLC. And this is the program number, the serial number of the machine, the date the program was made and loaded.
Is there anything alarming that tells you whether that backup battery is in there or not? That looks like the size battery I need for something.
In that case, the
there
thing
is a
goes
lot,
nuts. Yeah.
So don't screw with it.
You'll find out real quick somebody steals the battery.
Okay.
Because if it steals the battery, every time it boots, it has to reload the default program off the chip. So any changes we made to the configuration go away. Important thing is if you need to upgrade something or if there's an update, it'll come on a device like that, need to be put in.
So you just plug it in and it does
You shut the machine down, you plug it in, a couple of button sequences you push and it loads it up. On the other side here, this is the communications port. This is your Ethernet output to the local Ethernet switch from the PLC. This blue wire, if I remember correctly, this is the one that is going. Blue wire is the one that's going over to that machine and then to the master. This gray one is the one that's going to the digital display, the HMI, the display. So they've gotten rid of the serial, don't use the serial cables anymore, and anything that's all Ethernet communication, that display is actually Ethernet.
Yeah.
So sometimes the serial cables were an issue. No, theoretically they're not. Blue box here is the LawnWorks. That's the interface between the PLC and the LawnWorks system is the blue box.
These are on LawnWorks at the on graphics.
Oh, really? No adjustments can be made on it though, right?
No.
Someone can't start mouse clicking and start to screw with all
Yep.
these settings. All right.
Then we've got our main disconnect, 24 volt power, 460 to 24 volt power supply. Distribution block for the main power. And our main contactor set, these are all, again, they're not variable speed drives, but they're Y delta, so it's a soft start.
Okay.
Biggest thing to remember about this is if you have a motor overload trip, if it's the fan motor or the oil pump motor, it's going to be one of these. If it's tripped, this handle will be at 45 degrees.
Okay.
And in order to clear it out there, you have to turn it all the way off and then turn it back on
Okay. All right.
in order to
Almost
reset
like a
it.
breaker where you have to go to like full off.
Yep. Now the one that isn't is the main motor. That one you clear by hitting that blue button next to the red one. The red one's a test.
Okay.
Biggest thing to remember about this is it's Y delta. So all 6 leads to the motor are carrying basically half the amperage, but it's not really half. It's 58%.
Okay.
So that overload block needs to be set to 58% of whatever the full load coming in
okay.
is. So I see that a lot.
They don't
People taking the motor nameplate and set it the full motor nameplate. If you set that overload to full, about the max you want to set it to is 60% of
Okay.
whatever the motor is supposed to be doing.
Well, you'll burn the motor out if you set it up for.
Well, let's put it this way:
You're
if
taking
you
the overload out, right?
well, you're setting it 40% over if you put it
Yeah.
nameplate. If
Yeah.
you're at 40% over, the machine will be on fire long before it shuts down.
It doesn't
Right.
seem to be making any air.
Yeah. So, but an important point. That's true not only of these. Anything that's got a Y delta starter, the overload needs to be set at 58 to 60%. And you'd be amazed how often you open one up and I mean, I get phone calls all the time. They ship the wrong overload this machine. It's too small. Because if the scale on the overload won't go to the full load, they'll call you up and say it's too small. I can't set it right. And it's like, yeah, you
Right
can,
there.
yeah. It's like, yeah, you can set it right. Don't change it.
So now, is there a reset on the 24 volt transformer or no?
Nope. What there is a regulator.
Okay. Is there typically any issues ever with the 24 volt transformer?
I haven't had any.
Okay.
So, if you look at the size of it, the output's 5 amps. Usually people run these things off like 1.5 amps. So they've got a lot. Yeah, it's got a really good cushion. Now the reason they go to 5 is they have a 3 amp one. The reason they go to 5 is just to run the switch and the LawnWorks. All that's 24 volt. But I mean, they're really beefing it up, so it shouldn't be an issue. Oh, and I know you're still also using the regular standard monitoring system besides the LawnWorks that works off the relays.
Yeah.
So that's this bank of relays right here. One thing they have done in this version of the software is your OK relay, the one that says the machine's running
Yeah.
and is all right, is now energizing as soon as you power it up, where it didn't before. So they had to wire the contacts differently. And that's to comply with the NFPA regulation that if something loses power, they want an alarm. So now if it's powered up, now the downside of that is you shut it off to work on it.
You're going to get an alarm.
Well, right now, if they're actually paying attention to it, somebody's getting an alarm that this one's down.
Is this a separate operation manual for the machine with the display?
All right, so we come up, and of course, well, we're in local, but we're not on.
Okay.
And when I put it in remote, now even if we were on and local, when I toggle it to remote, it's still going to come up and it's going to say,
Once you get it to come on.
press start to enable it. So now once I do that,
Solid.
now it's told that
now it's
I'm
listening.
here, I'm ready.
All right.
Tell me where I am and what I should do.
Is that alarm, I'm assuming?
Yeah. Now if we look at this, if we look at the sequencer page on this, we will probably find out. Now remember 2 was the lead before, but we turned this one off and took it out of the sequence. So since this was out of the sequence, it rotated.
Okay.
It rotated pumps.
Why is one an alarm?
One is not an alarm.
That's alert.
One itself is not an alarm. That's the sequencer is getting an alarm.
Master's going to give all the alarms.
We have not acknowledged that this thing was down before. In other words, because we disconnected this thing, killed the power, and brought it back. If we go over there, it's going to say
We get acknowledged.
something about. Yep. So what's it telling us? I know what it's telling us. Somebody inadvertently hit the stop button on number 2. Take a look.
Oh, somebody lean on it? The emergency stop?
Either the E-stop, it's not saying E-stop, but it just says not ready. Now it's saying not ready because, is that machine on right now? Will that come on?
I don't think so.
Are we in local or remote?
I don't know. Hold on. We're in local.
Okay, so toggle it to remote.
All right, we're good.
It'll time out and shut itself off. Now you just got a lesson in why Larry doesn't use the sequencer over on the other side.
Never did anything to me. I might start though and play this time out. Even though it does my back.
Yeah, the sequence. Now what we were talking about as far as the sequencer, the set points for that, and just so you know the way to get into that in this machine, okay, when you go to the main panels,
You gonna run them on the sequencer over there?
okay, we go and you get the sequencer button, you touch that, this comes up. Now to get into the sequencer menu, again, think of it as a whole separate program, separate device. I got to hit the center of the screen again, just like we do on the main one. And now I get the sequencer configuration stuff and diagnostics. So if I want to go in and look at that, now this password's different. Well, if you buy me lunch,
It's almost lunchtime.
I haven't done anything major with these, but the password that gets you into that is base jump. First 4 letters caps, last 4 letters lowercase.
Jump.
Jump. Somebody at the factory likes the base jump. Somebody in the programming department.
Really? Cool.
Okay, so it's set up as a 3-station sequencer. Now, obviously, one of the things you can do with this, or gives you the facility, if you did have a machine that was going to be out for a couple of weeks, you could come in and tell it's a 2-station sequencer, and just make sure you have a direct wire connection to the machine that is going to be on. You know, the direct run to the Ethernet from the switch in that one to the switch in this one, rather than a daisy chain or whatever. But then you can fold it into being a 2-unit sequencer.
I wouldn't go that far.
Lag and use turned on, number of compressors for lag and use. So actually, we could actually set this lag and use would trigger. If normal you only need 1, if you wanted to, you could actually set the lag and use on this to trigger it 2. So it's fully configurable, and that's the calibration for that transducer up there. Now the settings. That's the one thing I don't like.
A lot of people make instructions coming up.
If you put this level password in on the first level, you know, the unit run screens. If you put the configuration password, it lets you into all of them. All right. So, startup delays, lead overlap to allow the sequences to shift. How long, you know, you shut down, the alarms go off for various things. There's a whole thing in that manual about the program that goes through what all these things are and what they mean.
Oh, it is, so it's all in
Yep,
there.
time clock, you know, the time clock, high, if you got an alarm pressure, high and low. How often it checks the pressure, basically it scans every 2 seconds. Small event, large event cycles. These are all adjustments. Now this is what I was talking about as far as pressure. High and low is 110. The normal high and low, that normal high and low are your settings where you want to keep the system. You know, that's what you're really looking to keep things between.
So if it goes high or low, I'm going to get an alarm?
If it goes
the high and low to the low.
You'll
Low.
Yeah.
Okay.
And like I said, the events are from the factory, that was 2 and 3. But that meant every time I had a float drain blow off and the pressure changed in the header by 3 pounds, everything went nuts. So we might actually end up wanting to make that bigger.
Okay.
We don't know yet. Because obviously you don't want to set it so big it doesn't come on when you need it, but you want to set it big enough that it doesn't.
You don't know what every application you have at drains.
Yep. But that's, you know, where everything is to do with the sequencer. And obviously, the biggest thing to remember is if you can't get it to run in the sequencer, just toggle them into local, put them in local.
Call you.
Call us, but
I get your number.
but the bottom line is, you know, same thing like on our vacuum systems. We have a bypass method. The most important thing I tell people in training is this is how you get it to run quick and dirty. While you're trying to remember, what did he say about resetting this and doing that? Meanwhile, you need something. Right. Turn it on. It buys you time. So with these, put them, you know, even if you're trying to fiddle with this one, put the other 2 in local. Hit the start buttons. Your system, right? Put one in lead, one in lag. Your system's good. You got no worries while you're figuring out what's going on.
Cool.
Because you leave this in sequencer, you can fiddle with it, mess with it, and figure out what's going on. And then once you figure out what's going on, you can. All right.
Comes the Zamboni.
Let's look at the quick overview of what the rest of the system is all about. These are a lot simpler. I hope. You're once you make the air, it's going through this header, and it's coming down and going into this wet tank. And it's also going into both tanks, right? Yeah, both of those tanks.
One tank to the next. Both of them are wet.
Yep. So it's basically going from one tank to the other. Each tank has an electric automatic drain on it. There's a 2 set points on those, one for how often it'll fire and one for how long it stays open. I was in a place last week, they put in a 3,500 gallon wet tank. So they want to run the system on a real tight deadband. Only problem is they took the same drain they had on their old 400 gallon tank, one of them, put it on and never changed the adjustment.
You're getting water everywhere right now.
They weren't getting it everywhere yet, but we were putting in a new sequencing system, and we went to a tap 3/4 of the way up the tank where there was a petcock and a gauge, and we put our new line on to run to our new transducer on the sequencing panel. And when we cracked the gauge, when we cracked the petcock, our new piece of tubing filled with water instantly. So we were 3/4 of the way up the side of that 24-foot tall tank. The good news is they were still 1.5 feet below the intake pipe, which would have brought the water back to the compressors and trashed the compressors. So it was kind of a good thing they had us in to do that. The other amazing thing is it was on a level where there were 2 more floors below it. So the interesting thing is the floor held.
Yeah, that's a lot of weight.
They had you know, it's a 3,000 gallon tank. I guarantee they had at least 2,000 gallons at 8 1/3 pounds a gallon in that tank. That is a lot of weight. So always good to have the manual drain line and check it. They did say they were checking the other one. They were pushing the test button on the drain and firing it off. It's, oh, there's water flowing out.
Yeah, not all of it.
But I looked at it. And they had it set to open 2 seconds every 25 minutes. So yeah, I'm figuring they were probably off by about 10 gallons a day because the new tank had been in for about 3 months. So I'm figuring if it was full of 2,000, you know, about 2,400 gallons, it was accumulating at 8 to 10 gallons a day. And it was a hot, muggy summer, so it made a lot of water. So you get your 2 wet tanks. Air comes from that, goes to 2 dryers in tandem. Now these are working the way, or set up to work the way the code says they should. We've got one on and one in reserve. So one in reserve is turned off, powered down, and valved off. By being powered down and valved off, it should be as dry as it was when we shut it down. It should, the internal system in here should be bone dry just like it was when we shut it down.
Okay.
The reason for powering it off, lots of guys will just shut the valves but not power them down. The problem is if you leave the power on, the solenoids keep actuating, letting the muffler port open to atmosphere in the room. So if you let it be the backup for 3 months, whatever ambient moisture is in the air here goes in through those solenoids and saturates the desiccant bed with ambient moisture. So when you turn it back on, it's wet. And you've got to run it for 12 to 24 hours to dry it out before you can put it online. And since in most cases you're going to be putting it online because, I mean, ideally you're going to be doing it once every month or once every 3 months, whatever your routine is, because that's just how you balance them out. But in an emergency, you're going to be putting it online in a hurry because the other one failed. So you don't want to have to wait 24 hours for this one to be good. So hence, valve them off, power them down. Now the way we power...
Drain them out at all?
Nope.
Just valve them off,
power them down.
Okay.
The selector switch here chooses which dryer. So right now we're on dryer A. This one's powered. If we switch it to dryer B, that one will power up. Okay. If we put it in the center, they're both powered. The center position is there. Say you did shut one down, or say you had to put this one on because this one failed and was wet. Now you repaired it. Now you want to dry it out before you put it back in standby. So in that case, you would leave the intake valve open. You would shut the outlet valve and leave it powered, and it would just cycle, drying itself out. Okay. And then once you were sure it was dry enough, then you shut the inlet valve, power it back down, or maybe even put that one back online and make sure it works. Okay. And valve out the other one.
Is that just a power light right there?
This, on the dryer, yeah, these are power lights.
Okay.
So this one's on, that one, no. If you need to work on it and disconnect it, you don't need to lock them out. They're plugged in right here. Now if you look, the plugs are labeled dryer A and B.
Wow.
And they're, yeah, because the duplex outlet in here is not standard. They're not interconnected. They're both separately wired through this switch. So dryer A is connected to this one, dryer B is connected to this one. If you switch them, you're going to be powering the wrong one.
So which one you plug your radio into?
That would be that one.
Yeah, I just you can see somebody unplugging
Okay, the other thing that's plugged in here is the carbon monoxide monitor. The carbon monoxide is plugged into there. Dew point's got 24 volts coming from here. This dew point monitor has 2 set points, one for the alarm, the local alarm here, which is the standard, triggers at 35, resets at 32. If it triggers, you have to clear it here if it's latched.
Does that one have to be cleaned like some of our other ones? With, has a mirror inside?
No, this one's a hygroscopic probe. The probe is mounted up here. There's a check valve here. and an adjustable muffler, so if you feel this with the back of your hand, you got a very small amount of air blowing out of it, just enough to keep the probe with some dry air mode, so you're not wasting much. But the other, there's a check valve in here, so that if you turn it off for some reason, the ambient air can't go back through and saturate the probe. That's usually the issue with these, is people turn them off, and even if you got a little pigtail on them, eventually some water molecules will get up there and saturate them. So put a simple low pressure check valve there.
What? It can't calibrate. There's no calibration on. No, we have to put another. We have to put another one in.
Yeah, we send them out to a factory.
Yeah.
No, we have to put another one in. We're not going to be sending that out. That's running dryer.
Yep. Now this one, the other thing this does is runs the dryer. You'll see that we have a thing here that says Purge Saver on. Okay, there's a second program set point on this, and that set point is set to minus, I believe on this one it's either minus 10 to plus 10 or minus 20 to 0, because we only need to be under 32 to 35. So I would try to give you about 20 degrees of cushion, so to speak, but there's no need to have this dryer shoot all the way down to minus 80, which is where it can go at full purge rate. But if it does that, you're using an awful lot of air to dry it. Normal, if we take this Purge Saver off, I'll probably start a compressor. It's controlled by this. If we turn this off, it's disconnected. The dryers default to working on their standard programming, which is they purge continuously, and each tower is online for 3 minutes. There's about a 30-second recharge, then 30-second recharge, then another 3 minutes of operating on the other tower. So,
When you say tower,
when you look at this,
towers are in each one of these systems?
you consider there were 2 towers. I mean, a dryer that has more capacity, they just extend this plate and put it right here. There's 2 banks,
Okay.
but there's a left and a right.
On each tower.
Yep. So the right tower is 2 banks.
Yeah.
The left tower is 2 banks.
Okay.
If you got a big, if you got one that had 10 times the capacity, the only thing different is
The number of banks.
the thing sticks out. You would stick out 8 feet to the rear.
Yeah.
There'd just be that many more, just that many more towers. So right now you see this one is, both towers are pressurized. The purge is suspended because our dew point.
Did you mean both banks? I'm not trying to be a
Yeah.
stickler for terminology.
No, but,
I don't want to get confused. Both banks, because this tower is pressurized, bank right and left of these 2 gauges.
right.
Okay.
This one's your left. This is the right.
All right.
Okay, so both of them are pressurized. The reason they're both pressurized, our dew point here is minus 20. So we don't need to purge, we're dry enough.
Okay.
So it suspends the purging. Internally, it's still switching these every 3 minutes, which one's online.
Okay.
No, the same tower doesn't, or the same bank doesn't stay online. It's its own programming is still switching. Left tower's on for 3 minutes, right tower's on for 3 minutes. But it's going to do that until the dew point gets high enough that the purge saver here goes off, and then it will run a purge cycle.
Okay.
Now, failing that, if it stays dry enough for 3 days, once every 8 hours, it will do 1 cycle just to,
Make sure everything's
yeah, that's automatic in the program. Once every 8 hours, it'll do 1 cycle just to make sure. Now, I'll show you how the real reason for this purge saver is when this is running, 15% of its air capacity gets vented out that muffler to dry the stuff out.
Okay.
Think of it like a sponge. There's literally hundreds of or thousands of beads in here that look like little beige or brown BBs.
Yeah.
Look at them under a microscope. There's literally hundreds of square feet of surface area in that bead. And they don't get mushy like a sponge, but basically the beads are designed to trap water vapor. So before the dryer, we have a pre-filter.
Right here.
That is a coalescing pre-filter. That's actually the after filter. There's another one down the back
Okay.
before it. The one in front is a pre-filter. That one's going to dump moisture all the time, because that's to prevent liquid water from getting into the beads.
So you want to get just as much water out. And
You want to knock out all liquids. The only thing those beads want to see is vapor.
They'll do nothing for actual water.
Actual water will turn them to mush.
Okay.
Once they turn to mush, you've lost the surface area and they don't work well.
That's fine.
So you're going to strip it down and clean it out.
How do you do that?
See all these bolts at the top?
Yeah.
You basically shut it down, disassemble that top cover, take the whole cover off, there's screens underneath, and then you get a shop vac. Well, the easiest way to do it is get a shop vac and suck it with a long wand and suck it all out.
Vacuum them all out and then fill it back up again.
Yeah.
From the top.
Normally on an oil-free compressor system, on a lubricated compressor system, those beads are usually good for 1 to 3 years, depending on how good the filters are
Yeah.
and how much oil gets to them.
Get into it. Yeah.
On an oil-free system like this, they should be good for 3 to 5 years.
At some point, we're going to have to change them, I guess.
Eventually, you have to either add to them or change them,
Yeah.
because every time the thing recharges,
It's kind of crushing some of those beads.
they rub together, and that's what this filter's for. And if you notice, the other ones have an auto drain on them.
This is
They'll drain
manual
moisture.
drain.
This just has a manual drain. You should never see any water at that point. That filter is to catch the dust that comes off the beads before it goes downstream.
Okay.
This is the final filter.
It's a final filter, catches the dust. Then we regulate the air down 58 or 55, whatever you're sending upstairs. Then you get the safety valve there that should be 75 pounds, I think is what's standard on a medical system. And then it comes over to all the sensors for dew point, CO, everything else, and goes out into the system wherever you're branching off to. If we turn this off, we'll show how it works normally. Okay, right now, left tower's on. Right tower's purging. If we go down and feel the muffler underneath, you'll feel damp air coming out of that muffler. Now, damp air, and it maybe condenses and makes a little moisture right there, is okay. If you see liquid water pouring out of there, very bad. Time to look at the pre-filter, figure out where the water's coming from. The maintenance on these is every 6 months or once a year if you're alternating the dryers. You want to change that inlet filter and the outlet filter, and you want to replace the muffler. That's basic annual maintenance.
Oh, you do want to replace the muffler every time?
You should replace the muffler because the muffler is also getting dusted from the beads. So eventually the muffler will build up enough dust that your gauge here, instead of reading 0, might read 2 or 3 pounds. The higher that pressure, the higher that back pressure, the less efficient the purge is going. So rule of thumb is change the mufflers too. Now that being said, if the gauge hasn't moved and you take it out and you blow it clean and very little dust comes out, sometimes you leave it till the next time. But again, if you're trying for no downtime, total preventive, you're better off to change the filters and the mufflers once a year. Now rebuilding the solenoid valves that do all the actuation and the check valves that internally is something you do every 2 or 3 years. Roughly, usually you figure about every 3 years. And that coincides normally with a 3-year desiccant life. But the desiccant could be 3 to 5, so when you're doing that rebuild, you would usually pop the cover, look at the desiccant. Now the big thing is, from rubbing together, if you've been losing a lot of dust, instead of being up here where it was when it shipped, it might be down lower. Now as long as, again, these can go to -80. So if we were only running to -20, there still may be plenty of capacity. If you're not having an issue,
Keep running. That's
Keep
kind of
running.
what we do with the desiccants across the street. Once
Yeah,
we start
you know.
noticing a high dew point, we change them out.
if you were in an industrial application or something that needed a -80 dew point,
You have to do all of
or -80 to -120, then you find yourself every year opening them up. And even if you're not changing it, you're adding a few pounds to bring the towers up to full. Because, you know, if you lose the top 6 inches and you got a really full, heavy load on it. The other thing to remember is these dryers are sized, this system's rated for NFPA. So the system rating is the output of 2 of these compressors, not 3. Because one compressor is always going to be a redundant backup. So the dryers are sized to each handle the full output of 2+ compressors.
running full bore at
So the point is, if you're not using that much, if you've only got one compressor running and it's only running half the time,
life should last.
again, if this purges, it purges 15% of its full capacity. So if it's full capacity is the output of 2.5 of those compressors, the purge out the muffler is 15% of that total cubic feet. So if we put both dryers on, we could end up using half the output, and we left it like this without the purge saver.
Right.
We might end up with a minus 80 dew point on both dryers. But the other thing we'd also end up with is we probably have one compressor running 50% of the time just to make the purge.
Yeah.
And that's obviously it's electricity, it's energy, it's wear and tear, it's maintenance. So now you notice it's switched.
Now we're on the other tower.
We're on the other tower. This one's pressurized, the other one's purging. And that's exactly, if you ever suspect the dew point's bad,
Are there
put it in this mode. Take the purge saver off and just let them cycle back and forth.